Hi, I'm Rob Jackson, student RLJ613 at Harvard's Science and Cooking. I want to follow up my Perfect Eggs video with a exposure that I think might be interesting from the standpoint of students to knowing some of the challenges that I faced in that project, which might come across as so simple and straightforward, but the truth is that I continue to be baffled to this day by what's going on in that thermos. So I want to talk about some of the misconceptions that I had, some of the challenges that I faced, and a open question for anybody who might have an answer. So I hope you enjoy it.
I started with a clear goal of wanting to know any types of loss in the system that could affect the number of joules that I would have to add other than cooking an egg itself. And after thinking it through, I decided that there were only a few basic types. Well, actually 7, but on a fundamental level, types of things that grew on a constant level and things that grew linearly based on some other changing things. For instance, delta T, or the number of joules for food, or how much water I had to add. So I went through the list of all of the losses I could imagine, classified each one into these categories, and concluded that many of them would be in fact negligible. In short, I decided that I could sample a few cases and determine from a few of them a line, apply what we learned in high school in geometry, that 2 points determine a line, find that line, use the constant in the line's function to determine the constant energy loss, and also from the line itself use that to represent the linear growth in joules needed, and I thought that I had everything taken care of. I had such a bias going into the experimentation that I was going to find a line that anything else I interpreted as error in measurement. And when I created the green line by computing it from 2 of the points in the research data, experimental data that I found, I ended up with a line that had a huge constant. And I tried cooking eggs. I was having lots of problems, started to look into it, and started realizing all of these things I couldn't explain. Most notably, why was there such a huge constant? I could not fathom that based on what I had been expecting to find. You can see here that if you took away the constant, the line that would be left over would be about a quarter of the size in terms of the number of joules. 3/4 of the joules were ending up being a constant, and I couldn't figure out why. There were other issues as well, that when I sampled other times for cooking, I realized that sometimes the line that I was creating would clearly produce negative results, which I could not explain.
So after I had hit this brick wall, I realized that there had to be something wrong with the way I was just thinking about the whole thing, and the more I thought about it, the more confused I became. I couldn't understand, where is all of the heat going? I couldn't understand how much heat could it take to heat up a thermos. A thermos is stainless steel on the inside. Stainless steel, a tiny level of stainless steel. Stainless steel has a tiny heat capacity. It's easy to heat up stainless steel, right? I mean, it's metal. And how much heat could a thermos be losing? What is it, junk? I couldn't understand. And then I started realizing probably the biggest expense, the biggest loss of heat, was when I poured out the water at the end, that most of the heat was in the form of water that got poured down the drain. And besides that most of the cost of retaining heat in the system wasn't the tiny amount of the walls from the thermos or the air. These things are negligible. It was the water itself. Water to maintain water. And I realized that conceptually there was a limit to what I could do of just trying to think through things. And I decided that I was just going to collect data and figure out what was going on at each point, and then afterwards develop a function to explain it. And fortunately, I came across regression analysis to find a way to do that. And so that's what started phase B. So I could talk for probably 10 minutes alone about all of the practical problems with getting everything to work right and getting everything set up right and everything else. All kinds of problems happened. But I think that I'd rather just stick with the higher level issues here.
I'd like to end with an open question. Really what I had wanted was to derive a function like this, where for any food and time and delta T, we could determine the number of joules needed to cook that food. I conjectured that we could start by deriving the number of joules needed for heating up the thermos itself by dividing our baseline function by the ratio. And my logic was that heating up the thermos is no different from heating up the food that I incrementally put into the thermos, such as the water. It should make sense that it grows at the same rate, the amount of joules needed to maintain that temperature. So I figured we could then take Q of thermos, add it to the Q of food, and the whole thing we could multiply by the ratio at time x. Unfortunately, the values that I found for Q10 blow this theory. Clearly, the values of Q of 10 are lower than the value of thermos by about a third. You can see the blue shows thermos and Q of 10 is shown in purple. I do not know why this doesn't work, and I'd love to hear from anybody who has any ideas.
So I would say that there are two things that I have learned from this course. One is there are times when there's a limit to what you can figure out intellectually and logically, and sometimes you just have to collect data, find out more, and then figure out how to understand it all. Another thing is that we are not as limited as we think. There's a lot that I can do. Even though I don't have a scientific background, I'm able to produce something that I think is pretty amazing. And you may have seen my name in some of my postings in recent homeworks, especially on helpful hints for doing the calculations. The reason I started doing that is because I saw that rather than feeling empowered by this course and feeling excited about, wow, look what I can accomplish with these equations, it was having the opposite effect for a lot of people. A lot of people were saying, this is too much for me, I can't handle it. It was disempowering. They were saying, oh, this isn't for me, I can't do these calculations. And we all can. And I hope that whatever it is you're trying to achieve in this project, in this course, in your life, that you realize that you can do it and you should never feel limited just because of your background.